In this video, we're going to look at trig integrals that involve even powers of sine or cosine. And the main trick here is going to come down to using three main identities. So we've looked at all three of these already, we've derived them. The first two are the half angle identities. And then the third one is this identity that relates sine of 2x to cosine and sine of x. So the classic question or classic example is just to do, say, the integral of cosine squared. And this is directly going to use the half angle to evaluate it. So we're just going to rewrite this. And now we can just integrate term by term. So now I'm going to get sine 2x over 2 plus a constant. So now using that idea, let's try cosine to the fourth of x. So take a minute, put this on pause, and see what you can get. Okay, so for this problem, we're going to rewrite this as cosine squared squared, and then I can replace this inside cosine squared using my half angle formula. And then I can just expand this out. Let's pull the 1/4 out front. And then these first two terms, this one and this one are going to be easy to integrate. When I get to this one, notice I can come back up to here, and everywhere I see an x, I replace it with a 2x. So I'm going to get this, and now I can just combine some like terms and then integrate term by term. So combining some like terms, I get this, and then we can just integrate term by term. And that's it. That gets us to our answer. So let's try one more. Okay, so here I have both sine and cosine raised to even powers. And so I want you to go ahead and put this on pause and try to use some of the identities that we've previously shown to do this one. Okay, so there's several different ways to do this, so I'm just going to show you one approach. One of the quickest ways to do this one is to notice you can break this up into sine squared. So I'm going to take out that from this first term, and then you're going to be left with a sine squared cosine squared, which we can write as sine of x cosine of x quantity squared. And again, I'm doing that because of these identities over here, which are going to be useful. And so now I'm going to replace both of these terms with their corresponding identity. And then we'll expand this out. And then for each of these terms, we're going to have a different approach. For this term here, we're just going to use the double angle formula. So we're going to come back up here and replace x with 2x. And then for this term here, we can use a u sub. And then we can just integrate each of these. And for this one, I know I'm going to get u cubed over 3 times 1/16. And then I can just replace this again with u. So I'm going to do all of this in one step. So I know I'll have sine cubed of 2x over 48. And then plus c. And again, there's different ways to do this. You should end up with the same answer. But that's one of the quickest ways. So in general, this will be the strategy that you use anytime both your sine and cosine powers are even.